Hello and welcome to everyone. In this video we are just going to interface 16x2 LCD with PIC16F877A microcontroller in 4-bit mode. Let's get started. So initially let's try to build the Proteus simulation circuit first, and then we will test the program that we are going to write in MPLAB X IDE in the hardware. So I'm just opening the Proteus 8 professional software. So we will be simulating the project and also we will be trying the program in the hardware. Click on this icon to open the schematic capture tab, and then click on this components mode icon, and then click on this P icon for opening the PIC devices tab. So the basic components required for our project is PIC16F877A microcontroller. Just type in the microcontroller name right over here. So this is the microcontroller. Double click on this microcontroller for selecting it. You can see the item has been selected and it is listed in the list of devices right over here on the left. And then we require 16x2 LCD that will be available in this Proteus 8 with the name of LM016L. So this is the 16x2 alphanumeric LCD. Just double click on this to select it. You can see the LCD is also selected. So other than this we don't require anything. Just click on OK. I am placing the microcontroller right over here in some of the places of schematic capture, and I am placing the LCD right over here. So now from the previous lecture of 16x2 LCD working explained in 4-bit mode, I have clearly explained you the circuit required for connecting it with a 8-bit microcontroller. So from this schematic you can see clearly only the 4 bits of the data lines of the LCDs are connected to the microcontroller port pins. Other than that, we will be leaving the D0 to D3 bits ideal. So I'm just going to connect the D4 to RB4, D5 to RB5, D6 to RB6 and D7 to RB7. And regarding the RS, RW and enable, I'm just going to connect it to RB0, RB1 and enable will be connected to RB2. That's it. That's all about the connections. We don't want to give the VSS, VDD and VEE pins in this simulation circuit. Since this is a simulation, it will be working fine, but in the hardware I will be showing you a different circuit. You just want to make the connections according to that schematic when you are building the circuit and trying out to get the output in the hardware. So that circuit I will be showing you later on in this same video. Now that the circuit that is required for simulating this project is ready in this Proteus 8 Professional, let's try to write some program onto this microcontroller for writing some data onto this LCD in 4-bit mode. So I'm just going to open the MPLAB X IDE software for writing down the programming part. I'm just clicking on this MPLAB X IDE, which we are going to use as a software tool for writing down our program for PIC16F877A microcontroller. So in the first tab of the MPLAB X IDE, just click on this file and then select the new project. Here in the first tab of the project wizard, just select the standalone project and click on next button. And here in the next tab, you just want to select the microcontroller or the device that you are working on. In our case, the device is PIC16F877A. Just type in the microcontroller name and then select it right over here. Afterwards, you can just click on next for moving forward. And in this tab you just want to select the compiler toolchains required for our project. Select the XC8 Compiler and then click on next. And in this name tab you just want to provide the name for your project. I'm just going to give the name here to be 4-bit LCD and you can choose the destination folder right over here in the project location. And after choosing the destination folder for the project files, just click on finish for creating your project. You can find the project that you have created on the left side projects tab right over here, and in the source file you just want to create the main.c file, which is the main source file for your program. Just right click on the source files and hover over the new, and here you can find the main.c. Just click on this and you can give the main.c file name as per your requirement or your wish, and then click on finish for creating the main.c file. And finally you can find the main.c file created after following all the steps that I have shown to you just right now. So this is the main.c file. So here as usual we just want to create the Xtalk frequency definition for using the millisecond and microsecond delay available in this XC8 compiler. So as define of underscore Xtal underscore freq, I'm just going to use the 20 megahertz crystal in the microcontroller. So I'm just giving the value to be 2,20,000,000. That's it. And coming into the main function, so before going into the main logic, we just want to write the basic functions required for LCD. So that we have already wrote in the previous lecture, and I have clearly explained about these two functions in the previous lecture, right? That is the LCD command function and LCD data function. So we are just going to use these two functions and convert it into XC8 format for interfacing LCD in 4-bit mode with our microcontroller. So before that, I'm just going to configure the GPIOs required for interfacing the LCD. So here you can see clearly the port B has been fully utilized for running this LCD or for writing data onto this LCD. So I just want to declare all the port B pins as output. So for declaring and configuring a particular port as output, I just want to write 0 to the tris register, right? So I'm just going to write here in the main function tris B is equal to 0x00, which means all the port B pins configured as outputs, and below it I'm just going to write the while of 1, which is the infinite loop of the program. So here is where we are just going to write the programming logic which needs to be executed again and again in the program. So here we will be writing the configuration sections. So now I'm just copying the LCD command function and I'm pasting it right over here. And here from our schematic you can see clearly the RS pin has been connected to the RB0, RW is connected to RB1, and enable pin is connected to RB2. So I'm just going to make the definitions for these pins as define of RS is nothing but RB0. So I'm just going to write port B bits dot RB0, and nextly I'm just going to define the RW pin, which is nothing but port B bits dot RB1, and the next pin is enable pin, which is nothing but port B bits dot RB2. So we have successfully configured and defined the RS, RW and enable pin of the microcontroller as per the schematic that we have connected in the Proteus 8 Professional. And nextly, I'm just going to convert the data lines of the LCD which is connected to the MSB of the port B register. So as per the programming logic here, you can see I just want to write the command that I want to write to the data lines to the port B. So I am changing here to be port B. And the delay that is available in this MPLAB X IDE is __ delay _ ms, and here also I just want to change it to be __ delay _ ms, which is a millisecond delay available in this MPLAB X IDE. So you can see clearly our LCD command function is ready for operation, and similarly I am just going to change the LCD data function here. I am copying it and I am pasting it beneath this LCD command function and changing this to be port B, and that's it. You can see clearly the LCD command and LCD data function has been converted into the format required for operation in this MPLAB X IDE. Similar to this, you can use these two functions that I have taught in the previous lecture for any microcontroller for interfacing LCD in 4-bit format. The only thing is you just want to connect the MSB data lines of the LCD to any one of the port MSB data lines, like RB4 to RB7 is connected to D4 to D7 of the LCD. And nextly, we just want to write another function, that is LCD initialization function. So similar to the initialization function that we wrote for 8-bit mode of LCD in interfacing of LCD with PIC16F877A microcontroller lecture, we are just going to write the initialization function for interfacing this LCD in 4-bit format for now. So for that, we just want to use several commands from the LCD. First command is 0x02 and the second command is 0x28, which means we are just going to use the 4-bit mode of LCD, and we are just going to utilize the 16 columns and 2 rows of LCD. And following that, we are just going to write 0x0c, which means cursor off and display on. And the next command is 0x06, which means auto increment the cursor when the current value in the LCD is printed. And the final command that we want to give is 0x01, which means clear screen. And that's it. And following that, we also want to write another function which is useful for printing string to the LCD. That is nothing but word to the LCD. So from the previous lecture of interfacing LCD in 8-bit mode to PIC16F877A microcontroller, we wrote this function. I hope you remember this, LCD string, which is useful for printing string onto the LCD. So I'm just going to copy this and I'm going to use that as the same function in this lecture also. I'm copying this and I'm pasting it right over here in this program. So you can clearly see no change needs to be done over to this function. We are using the LCD data function right over here inside a loop for printing a sequential of data available in this array that is received in this LCD string function. That's it. I'm just going to call this LCD initialization function here in the configuration part of the program, and finally inside the while of one, that is the infinite loop, I'm just going to give the command 0x80, which means go to the first row, first column of the LCD, and I'm going to print the string some training, which is having the character length of 11, and then I'm just going to 0xc0, and then I'm just going to provide the command 0xc0, which means I'm telling the cursor of the LCD to go to the second row, first column of the LCD, and then print the string academy. So academy is having the total characters of 7. Okay, now I'm terminating it, and that's all about the program that I have written, and that's all about the programming logic that I want to build. You can clearly see here the programming logic is simple. I have configured the TRISC-B pins, every pin available in the port B as output, and then I have initialized the LCD with the following commands right over here. That is in 4-bit format utilizing 16 columns and 2 rows, and then I am just turning on the LCD with cursor off by giving the command 0xC0 and auto increment and clear screen. And following that, here I am going to the first row first column of the LCD and I am printing the string some training. And following that, I am just going to the second row first column of the LCD and I am going to print the string academy. That's all about the program. I am just going to build this program. You can see the build is successful. For now, I just want to write the configuration bits for this microcontroller. For that, click on this production tab and click on set configuration bits. Here in this tab shown right over here, select the F oscillator to be HS oscillator, which I am going to use is 20 MHz, and I don't want the watchdog timer. I am turning off the watchdog timer, and regarding the brownout reset, let it be turned off, and that's it. Now I'm just going to generate the source code to output. Here is the configuration bits that has been generated for your microcontroller. Just copy these lines, just copy these lines and paste it above this header files. That's it. Now build your project. The build is successful. Now first let's test the program that we wrote in the Proteus simulation, and then we will test the program that we wrote in the hardware development board. Double click on this microcontroller and type the clock frequency to be 20 MHz and click on the program files icon right over here and go to the respective destination folder where you have stored the program files. And inside the dist folder, inside the default protection folder, you will find this hex file. Click on this and click on open and then click on OK. Now when I play the simulation, as per the programming logic that we have written, the string SM training will be printed on the first row first column of the LCD, and following that the academy will be printed on the second row first column of the LCD. So I'm just playing the simulation by clicking on the play button in the left bottom corner of the window. You can see our program is working fine and the SM training academy string has been successfully printed on the LCD as per the command provided in our program. You can see clearly SM training has been printed in the first line of the LCD and academy string is printed on the second line of the LCD. So our program is working fine in the Proteus simulation. Let's see the output in the hardware development board. For uploading the program onto the microcontroller, firstly power up the development board using external 12V 1A adapter through this socket provided, and then connect the PIC3 to your PC USB port using mini USB cable. Then the terminals of PIC3 are connected to the microcontroller as per this circuit diagram. If your development board is not showing these pinouts, or if you are not having a development board, you can connect the terminals of PIC3 to the microcontroller port pins as per this circuit diagram. Or you can just build this circuit in a breadboard for programming the microcontroller. Once the circuit is built, click on this Make and Program Device Main Project icon. You can see the device is being programmed. Click on OK. And the program and verification is complete. And that's it. The program has been uploaded to your microcontroller. So now build this circuit to see the output in the hardware.
You can see I have connected the LCD in 4-bit format to the PIC16F877A microcontroller, and this is the RS pin, and it has been connected to RB0 right over here. You can see this is the RB0, this is the port B, and I have connected the RB0 to the RS pin of the LCD, and RW is connected to RB1 of LCD. You can see RB1 of the microcontroller, and RB2 is connected to enable pin of the LCD. You can see the enable pin is right over here, and it is connected to RB2. And regarding the data lines in 4-bit format, that is D4, D5, D6 and D7, I have connected it to RB4, RB5, RB6 and RB7. You can see these are the 4 data lines available over here. RB4, RB5, RB6 and RB7 is connected to D4 to D7 of the LCD. And regarding the power connections for the LCD, that is this one ground, VCC and contrast pin of the LCD along with the cathode and anode of the backlight of the LCD. It has been already connected to the power source from this development board, and this variable resistor is connected to the contrast pin of the LCD so that you can vary the contrast of the font available in the LCD with the help of this variable resistor. So we don't want to worry about that. I just want to power up this development board with this power jack so that this LCD available over here will be automatically powered up from the power source from this power jack. So let's see the output in the hardware. And this is the output that I got in my hardware. You can see SM training is printed on the first row first column of the LCD, and academy is printed on the second row first column of the LCD. And using this potentiometer available over here, which is connected to VEE of the LCD, you can directly vary the contrast of the font available in the LCD. You can see this is the maximum contrast and this is the minimum contrast. You can see everything is invisible and this seems to be okay.
So this is the output that I got in the hardware. See you in the next video. Thanks for watching.